Okay, good morning. Welcome back. Before we jump into the math for today, just a quick piece of info about a scholarship that is going to be given out to some GCC student very soon, but it might apply to none of you, so let's just check and see. You need to be a new GCC student that is new this semester. You need to be a single mother, and you need to have a GED. As opposed to like a high school diploma. So that is going to eliminate almost everybody at GCC, but if anybody in this room satisfies those three conditions, see me right after class and we might be able to get you $1,600. Questions on that? Okay. All right. So we'll look at our calendar. Today, Friday the 15th, it's our fifth lesson. Today we're going to cover something called slope. Raise your hand if you've seen slope in some other math class before. Yeah, so that's everybody. So hopefully this will be a review. And then Monday coming up, we're doing equations of lines, mostly mx plus b, which again, I think many of us have seen before. But just continuing to look into the future. On Wednesday, September 20th, you see it says quest number 1. So first, the word quest is a combination of the word quiz and test. So on that day, we are going to come in and individually take a quiz/test. It's on, like, I would say it's like bigger than a quiz, but smaller than a test, and so that's why we're calling it a quest. Come on in. Math 096? Yeah, okay. Why don't you, yeah, why don't you sit over there at that table? Okay. Okay, so in terms of this particular quiz/test, it is on the lessons numbered 1 through 5. Today, on slope, is lesson number 5. So at the end of today is the end of the new material for that quest coming up on Wednesday. Monday, we're just going to do new stuff, but it's not going to be on the quest, okay? Quest material ends at the end of today. In terms of preparing for that quest, so you got lots of good sources for problems. You got all of the homework problems that you've been doing for the whole semester, and then plenty of other problems in your textbook that I didn't assign for homework, but that are near the homework problems. You got all the problems in the packet, including the even more practice sections. But then you've also got that practice problems packet. I think we talked about it on the first or second day. I'll just pull it up again to remind you of what this thing looks like here. There's some good stuff going on with the practice problems packet. So first of all, again, the quiz is only on lessons 1 through 5. So on this very first page of this Word document is going to be a big old grid, and that grid is going to help guide you to decide which problems in this big packet we are supposed to take a look at. And, all right, there we go. So here we are on the first page of this practice problems packet, which I handed out a while back. So lessons 1 through 5 are right here. In this packet, you should be focusing on these problems. Don't do them in order. Do these particular problems. Or maybe, hey, I need more practice with dimensional analysis. Just do these 5 problems in this packet, okay? And a couple of nice things about the problems in this packet compared to all the other problems I just mentioned is that number 1, okay, so at the end of this packet, there's an answer key. That's pretty common for the stuff I give you. But if you go on Moodle, you'll also find full color solutions to all the problems here. That is step by step, like I worked through all this stuff on the smartboard in an empty classroom one day and saved it as a PDF for you. And also, when I was in that empty classroom, I recorded videos of me solving these problems. And so if you go onto YouTube and type in something like this, 096 practice problem 25, mine will be the first link, and you can watch me solving problem number 25 in this particular packet. And so my thinking was here is that if you happen to wait to study for Wednesday's quest until, you know, like Wednesday morning at 3, you have my cell phone number, but don't call me Wednesday morning at 3. But if you get stuck on one of these problems, you do have access to me if you go on YouTube and have access to the internet, okay? So lots of good resources for you available. We are not going to like take a class period to review for Wednesday's quest. Like I'm telling you now, it's coming up between now and Wednesday. You got lots of time, hopefully, to study for this thing. And one other piece of news for you heading into Wednesday's quest is that you are welcome to bring in and use a one-page cheat sheet during that quest. So between now and Wednesday, make something. Front and back, 1 page, 8.5 by 11. Don't bring in like a poster board or something. So just like a regular piece of paper. You can put anything that you want on it, including definitions, including theorems, including formulas, including practice problems with step-by-step solutions all the way written out, anything that you want. You can put on there lyrics to your favorite Taylor Swift song. I don't know. Whatever you want to put on there to help you during the quiz, you put it. The only rules are don't photocopy something, not from the textbook, not from my packets, not somebody else's cheat sheet. Just make it yours, okay? And I think that spending the time to really go through and decide what's important enough to go on your cheat sheet is a good part of a healthy study plan, right? Okay, any questions on any of that? Alrighty, so here we are on page 35. So let's jump in with our daily summary. In this lesson, we define the slope of a line and we see several ways to calculate and use slope. Number one, portion of road A climbs steadily for 120 feet over a horizontal distance of 4,250 feet. Here's a diagram. So just to be clear, that thing right there is the road, and we're looking at it sideways, and it climbs vertically 120 feet over a horizontal of 4,250 feet. Notice that this picture is wildly out of scale, right? The 4,250 should be way longer compared to this vertical, but doesn't matter for our purposes. And then we've got another road, not pictured here, which climbs steadily for 95 feet over a horizontal distance of 2,875 feet. So can you guys first draw another triangle and write those two other numbers on it? So we're making a road B triangle. Just have to make sure you put the vertical and the horizontal on the right pieces. Okay, I've got other stuff for you as well, but I can't grab it right now. See me right after class. Okay, so we've got this picture here, and we've got, this is road B. Which one is the vertical? 95 there. And then 2875 there. Again, wildly out of scale. So the question is this: which road is steeper? Which road is steeper? If you were walking up these hills, which one would be more challenging to walk up? And the reason this is not an obvious answer is that, okay, well, look, hey, 120 is bigger than 95. So does it just follow that road A is steeper because it's got more vertical change? What's wrong with that reasoning? What distance? What distance is different? The horizontal distance is different. Yes, it's true, road A climbs more, but road A also takes longer horizontally to get there. And so it's really the combination of those two numbers that determines how steep it is. You can't tell me how steep it is just by looking at the vertical. You need to account for how long horizontally does it take to do that vertical. So we are going to do some calculations here. I'm going to highlight in yellow. We are going to find the ratio. What math word does that mean? Add, subtract, multiply, or divide? Divide. So we're going to find the ratio. We're going to divide the vertical change to the horizontal change. We've seen this ratio business recently. When we see the word 2 there, which one is going on top? The first one or the second one? First one, right? So vertical change on top of horizontal change. Or one of them is already written out for you for road A. 120 is the vertical change on top. 4,250 is the horizontal change on the bottom. Go ahead and fill in the two numbers for road B. All right, which one goes up above? 95, and then we divide by 2875. If somebody, I don't need everybody, but if somebody could take a calculator out and just type that in for us. And while we're waiting, I'll say that I already typed in the other one. 120 divided by 4,250 is 0.028, whatever that means. Anybody have a number for us for road B? .033. Great. Okay, so we've got these two numbers, these two things that I'm calling the steepness of the roads, 0.028 and 0.033. And just by looking at those two, I want us to get to a point where we can say, oh, definitively, this one is steeper than that one. Road A is steeper than B, or the other way. So clearly it's going to have to do with, like which one is smaller or which one is bigger, but I don't know yet. I got to figure that part out. So let's say this. This 0.028, if I really wanted to force it to be a fraction, I could divide it by 1, right? That doesn't change anything. And this one I can divide by 1, and that doesn't change anything. And so if I think about the two numbers that I have in the first fraction, 0.028 over 1, well, that's still vertical change over horizontal change. It's just been like reduced to a decimal. But the horizontal change is now 1 foot. I can think of the horizontal as being 1 foot and the vertical as being 0.028 feet, not very much. And over here in the other fraction, the vertical is 0.033 and the horizontal is 1 foot. And what's the horizontal now for both of them? 1 foot, right? The bottom number is the same for both of them. And this gets exactly at what Kara had said was the problem before. We couldn't just look at the vertical numbers before because they happened over different horizontal distances. But now they're happening over exactly the same horizontal distance. They're both 1 foot over horizontally. And road A climbs 0.028 feet over that 1 foot horizontal, and road B climbs 0.033 feet. Which one is steeper? B, because it's bigger, right? We can say that now. So here's a sentence. You don't have to write it, it's just written already. Since the steepness of B, 0.033, is greater than the steepness of A, 0.028, road B is steeper. Notice that both of the steepness numbers are in that sentence. That's what I'm looking for from you guys. Before we move on to number 2, I'm going to say, again, we've got this quest coming up on Wednesday. I really like this question. Yeah, no, the one we just did with the roads. Everybody with me? I like this question. Yeah. Okay, number 2. So our definition. To measure the steepness or slope. I'm not defining slope, but it's the same as the steepness numbers we just did. Don't worry about that non-vertical part right now. To measure the slope of a line, we use the ratio that measures the vertical change in the y-coordinates, which you might think of as a rise, vertical, to the horizontal change in x-coordinate, which you might have heard called a run, running horizontally, rising vertically. So shorthand notation, we'll come back to that. We use the letter M for slope. You probably saw that in a previous math class. So here is a big old set of equations, all representing slope. We use the letter M. It is the change in y coordinate over the change in x coordinate. That makes a lot of sense. Vertical is the y part, horizontal is the x. It's still in exactly the same order as our road calculations. Don't get lost in the subscripts in this next one, but y2 and y1 are just the 2 different y coordinates that we are going to subtract. We just got to figure out how far apart the thing happens vertically. Anybody know this Greek letter here? It does stand for change, but what is it called in English? Like the letter starts with a D. Delta is good. So that is the Greek capital D. We call it delta in English, and it often stands for a change in math or science. And so change in y over change in x, that's our shorthand way of writing it. And then lastly, rise over run. All of these, again, are vertical over horizontal. Vertical change over horizontal change. So let's see a calculation in action here. In a previous class, we graphed this equation, y equals negative 200x plus 800, and I'll give you the context. It gave the altitude y of a hot air balloon in feet, x minutes after releasing air from the balloon. Do we remember this from the, I think it was the last activity or maybe 2 activities ago. Okay, and there was our graph of the equation. So what we are going to do is calculate the slope of this line, something, we did a lot of stuff with that line the other day, but we never calculated slope because we didn't have that word until right now. So here's how we do it. You pick 2 points on the line. Let's go with the 2 points that I picked here, but there are lots of other options. 0, 800, right up there. Go ahead and put a dot and label it. And do the other one as well, 3, 200. Okay, I'm going to draw something in that I don't need you to draw in, but I'm going to draw this in here. I'm going to draw in a green thing there and an orange thing here. And by drawing those 2 things in, I'm going to try to convince you, hey, this is just like the road, right? There's my road triangle. And if I wanted to calculate the steepness of the road, I would do the vertical change, which is colored green, divided by the horizontal change, which is colored orange. So let's just look at the vertical. How much is the vertical change here? How much is it? 6. I think these are hundreds, right? So 600. Remember with me, right? Because we're up here at 800 and down here at 200, and that is a total of 600. So I can label that right there. That's my vertical change. And how about the horizontal change, which is orange? That's just 3. There's no hundreds on this one. This is just plain old 3. And so if I want to think about my slope, which one goes on top? The horizontal or the vertical? Vertical always goes on top. So 600 divided by 3, 600 divided by 3, 200. Okay, so it turns out 200 is almost the right answer. Anybody know what the right answer is? So that 200 is pretty good, but it does not take into account whether we are going uphill or downhill on this line. And so if I'm thinking about, for example, like if I decide that I'm going to go this point to that point, and notice the order, right? Notice that there's a direction happening there. So let's take a look at the vertical. Are we doing like a positive 600 or a negative 600, would you say, in this direction? That's a positive, right? You're going up. So positive 600, that feels good to me. But again, you're still going in the same direction according to that arrow. So I'm going from right to left. Is that a positive or a negative 3? That feels like negative, right? Because we're going left. Negative x's in this direction. So really, it is a negative 3 there, which makes the right answer a negative 200. And that's the slope of this line. But if you just pay attention to the coordinates of the points, you don't even have to worry about forgetting, oh, is one of them positive, is the other negative? I don't know. If you just pay attention to the coordinates, so for example, I could do 800 minus 200 in that direction. That's my 600. And I can do 0 minus 3 in the same direction, and that's negative 3. And so all of that is listed right there. 800 minus 200 over 0 minus 3. You don't even need the picture, but I like having the picture in the beginning just because it's the road. That's all it is. Okay, let's play the same game, but with 2 different points. So can somebody pick a point other than these 2 points that are in blue here, whose coordinates are easy to read from the grid? Say it again? Well, you got to pick something on my diagonal line here. 2 and 400. That looks like, okay, so 2 400, and then I heard 1 600. That sounds good to me too. So go ahead and put labels on those points if you have room in your picture. And let's do our calculation. Okay, what letter do we use for slope? M. M equals. Big blank fraction, give yourself space to do the calculation. Up on top is supposed to be the vertical change always. Am I doing x's or y's on top? Y's on top. So I'm looking at my 600 and my 400 and I'm subtracting them, and it makes no difference what order I subtract in. I'll do 600 minus 400. And then downstairs I'm supposed to subtract the x's, but now it makes all the difference in the world what order I subtract in. I need to subtract in the same order I did for the y's. So if I did 600 minus 400, I have to do in the same order 1 minus 2. See it? 600 minus 400, don't do 2 minus 1. That's not going to work. 1 minus 2 down here, and then we just do the arithmetic. Positive 200 on top, negative 1 on the bottom. What is that really equal to? Negative 200. That's the slope. How does that slope compare to the slope from the 2 blue points we started with? Does that final number compare? Same. Same. Doesn't make any difference what points you pick. The slope of a line is just a number. Any points are fine. Okay, on the next page. All right, so here's a question. What does the slope mean in this situation? For me, if you ask me to write a sentence interpreting slope, I always write my units first. So what are the units? Well, that 600 from the first calculation we did together was 600 feet, right? We were at 800 feet, and then we fell down to 200 feet, and we lost 600 feet. So 600 feet, and then it took 3 minutes for that thing to happen, yeah? Feet on the vertical, minutes on the horizontal. So my units are feet on top and minutes on the bottom, or maybe said in more plain English, feet, and then what word could I use instead of like division or fraction line? Feet, blank, minute. What? Yeah, it is a ratio. Per. Per is the user-friendly word we want, right? That is feet per minute. That's what it means. And so if I'm writing a sentence, it is for sure going to have the phrase feet per minute, and it's going to have the number negative 200 in it. So here are 3 options for you for choices. You could, here's a good sentence. The balloon's altitude was changing at negative 200 feet per minute. Good? That's a full credit sentence. Here's a slightly better sentence. To say that we're changing at negative 200 really means we're going which way? Down. And so if instead you say the balloon's altitude was decreasing at 200 feet per minute, that's just a little bit nicer to the reader, right? Instead of making them interpret the negative. Notice, though, that I didn't say decreasing at negative 200 feet per minute. That would be wrong. Decreasing takes care of the negative sign, and we lose the negative sign when we write it, okay? All right, and then finally, the best sentence, the balloon was falling at 200 feet per minute. All 3 are full credit. They're all fine. Just get me some units in there and make sure that you make it clear you understand something is changing. Slope represents a rate of change. Okay. In terms of calculating slope, there's really only 2 ways that I've seen people go wrong. You might put the wrong thing on top, like you could just flip it over. So always y's on top and x's on the bottom. In terms of trying to remember that and not flip them over, one of my students a couple of semesters ago said, hey, why, you know, how do I know? Why do we put y's on top instead of x's? And I said, I don't know why we put y's on top. And so he said, okay, that's memorable. I don't know why y goes on top. Like that was how he remembered to put y on top. Okay, and then the other pitfall is to subtract in inconsistent order. So here we go, 0, 800, and 3, 200. Those are the points we started with. You could do 800 minus 200 on top, and then 0 minus 3 on the bottom. Notice the arrows going in the same direction. Or you could do on top 200 minus 800, and then on the bottom what? 3 minus 0. Totally fine. You'll get exactly the same answer, the right answer. But you cannot do 800 minus 200 on top. What color is that? That's green. And then 3 minus 0 on the bottom. What color is that? Blue. That is no good. Just subtract in a consistent order, and you will be fine. Okay? Okay. All right, so the activity is on the next page. Just read carefully, and I will walk around.